0 sodas to 1 soda. When I'm thinking about those two different states of the world, I have 1 burger, 0 sodas, and 1 burger and 1 soda. And the other situation is 5 burger, 0 soda, and 5 burger, 1 soda. So where do you think that the additional happiness of that soda will be bigger? Now, there's no rule, right? Somebody said they really like the soda at the first moment. Then they said, well, at the 5th burger, I'm already full. I do not want anything more in my stomach. And they said, I want marginal utility of soda to be lower in the second case. That's absolutely reasonable. There's nothing in econ that says that can't be so. If you're like me, I'm thinking I had all those soda burgers. I either had 1 burger or 5 burgers, and I'm thinking I am full, and my palate is very dry. So I want that soda. So in that case, I think for many people, the marginal utility of a soda would be higher in this case rather than that case. I'm just using this as a way to use the vocab so you can hear it and see if you can follow along with the story. It's always good to be able to break down the equations and the formulas and all the things we keep track of in a column into a story, because our brains are wired to understand stories a lot better than numbers. So here's some stories for you. So now we're working in bundle space. So we're not talking about price and quantity of one good, we're talking about the quantity of each of those goods. And if I could think about something, with each of these points is associated a utility. So this little 3-dimensional thing that I've created, and I talked about level sets, imagine that there's something called utility mountain here, okay? And utility mountain is what we're trying to, that for every point there's a certain height that extends out of the board. And that height represents its utility. Down here at 0, 0, let's call that our reference point, 0 utility, sea level. Up here is Mount Everest, very, very tall, very, very high utility. And these other points, we want to figure out where the utility is for each of those points. To draw in 3 dimensions would probably be the best way to do this, but making you draw in 3 dimensions, seeing some of your homework turned in, it's not very pretty. So we have a different way of doing it. We use something called indifference curves. So difference curves are sets of bundles that give the consumer the same utility. So if you like the story of utility mountain, think utility mountain and the same elevation, the same height of utility mountain. So 1 curve per level of utility. Already a student asked me a question saying, why do you only have 2 indifference curves? Aren't there more indifference curves? Or why did you draw 2, not 1? There's actually a million indifference curves, because with every single point in our bundle space, there's going to be a utility. And so when we start assigning numbers, we start collecting all of them that have the same number or the same elevation extending out. So here, very close. Here, a little taller. Out there, very tall. And then when we get all those numbers, and we, instead of using numbers, use colors and ask people to pick the same elevation, when we connect all of those points, we get an indifference curve. Right? So I've drawn 2 indifference curves here. Is there an indifference curve here? Yes. Is there an indifference curve here?
Yes.
Yes. Because every point has a utility, and then the indifference curve, there's some indifference curve that connects this to the other points that have the same utility as that point. Okay? So much better the second time around, right? So seeing this the second time. Is there an indifference curve in between? Yes. Every point is on the same, is on some indifference curve, even if we don't draw it. So there's an indifference curve there, an indifference curve there, an indifference curve there, etc., etc. So if you like topographical maps and you like utility mountain, which I'm encouraged to use sillier and sillier stories because they stick in your brain, we have something where you have different steps, S-T-E-P-P-E-S, steps, like terraces, land, and so each of these is in at the same level, so they draw the level set, the level set, the level set. Okay? That's what we're doing when we're drawing the level sets for indifference curves. In this case, we have a peak, but in utility space, we don't have a peak because it keeps on extending further and further up as we go up and further. Yes, questions?
So for each point, there's like a unit or what
Yeah.
What does that mean here? Because I saw like there's from 1 to 2. Like,
yeah.
what does it mean for each one?
So I think Brett's question is relating around, we've looked a lot about, usually with these curves, we plug in something in X and we get something out at Y. So I think what you're trying to ask is, what is the line gives us a machine. So you plug in a Hershey's quantity and you get out a Reese's quantity. That machine is, when you pick an indifference curve, you're picking a level of utility, an elevation on utility mountain. And what this says is, given this Hershey's, what is the amount of Reese's to get that utility? Given this Hershey's, what is the amount of Reese's to get that? Yeah, so it would be 5 Hershey's, 5 Reese's, or 7 Hershey's, 4 Reese's, or 10 Hershey's, 3 Reese's at the same time. So it's like I'm being given a bowl, and I'm being asked to choose which of these bowls do you like better. And you can imagine, I don't know, this is probably like 15 by 15, a lot of different bowls. So these are all the bowls that have the same, not the same number of candies, but the same utility of candies. These also get interpreted as, I'm going to hold off on the interpretation. You're more familiar with the Ithaca topography. Your shoes will get worn out in your 4 years, so buy better shoes next year. And this is slope, for slope day in May. You can party there. So lower elevation, slightly higher, et cetera, et cetera. Okay. So the interpretation, to get back to Brett's question, is this talks about trade-offs. So what I'm saying is, if I'm here at 5 Hershey's, and I say, excuse me, Mr. Brett, we run out of Hershey's. We actually need to take 2 Hershey's away from you. What can we do to make up for that loss of utility? This tells you how much utility as you're moving from point to point. So there's a movement from point to point, and there's also a reading of what the bundles are from the axis. Very good question. I'm sure many people were thinking of it, and you got to ask it. So I'm happy. Okay.
Well, does it ever plateau? Like, I have enough Reese's and Hershey's, I don't really want any more.
You could think of it as plateauing, but what you'll find is we don't really show and discuss it in this curve, but you'll see that they are further and further spaced out. So if you think that going from this curve to this curve is increasing utility a set amount, then the next one is going to take even more stuff to get to. So it's going to get a little less and less. So if I chose just bundles along this 45-degree line, then the first one is going to be pretty good. The second, third, and it's going to sort of trail off, diminishing margin of utility. That's important somewhat to services, because the right question isn't to ask, does this person prefer more of the good? The right question is, which good do we want to give the client, the customer? So when you go to restaurants, you can think of it the decor, the service, and the food. There's diminishing marginal utility from each of those things. So once you get the food really good, another unit of food may not be very valuable to the person utility. But if the decor is pretty bad, so you think of it, food really good, decor bad. So Glenwood Pines, if you've been there. That's just an aside joke for the locals. So if the food's good but the decor is not so good, if you spend the same amount of money thinking, do I want to increase the food quality or increase the decor quality, you'll think that the decor quality is probably going to give you more bang for the buck, which gets us to something we talked about last time we haven't gone to yet. So Stephanie and then Brett.
I was going to, one of the questions on the homework alluded to a indifference curve that would actually look like a supply curve where it starts at the origin and extends upwards and to the right. But didn't you want, in the book it also said, I think that's not possible. Is that?
Is it that one right there?
The shoe problem?
Is it that one?
Well,
Oh, I don't see one.
It makes sense. There's
None of them are upward sloping.
Yeah, none of them here are. It's just,
Okay.
Is it possible?
for perfect complements, I would assume that since you need to have both in equal quantities to be the most happy, wouldn't it make
With the
sense
same
to?
utility,
So I'm going to read your mind and answer the question I think
I
you're
see what you're
asking.
saying.
I think it asks to draw a,
No,
one
I
that
see what you're
breaks
saying.
the rule.
You're saying, but
I'm
if
not
you have
I
two pairs
think
of shoes
maybe
here,
on
you
on
have
the
two
quiz
pairs.
I gave
And
you, I
just-
asked you to
have
draw
two
something
right-
that breaks
two
the
right
rule.
size
Yeah,
shoes, you
that's
need
right.
two right left
So,
size shoes, right? If you have
anytime,
four,
so
you get
this
four
actually
shoes total.
fits
This
into
is
what
a higher marginal
is
utility.
happening
It's
here.
higher utility, so it's higher
So
satisfaction.
more is
Technically, these
preferred to
are the
less.
same.
So that's why it's never
But
allowed
It makes sense.
bundle X
Because
or good
it's
X,
this way,
good
right?
Y.
You have two pairs of shoes that you
You're
can
never
wear.
allowed
Even
to
if you have
connect
more
2
of
points
this,
that
the
are more of
satisfaction
both
level is
goods.
gonna be the same.
So
because
moving
you
this
only
way, you get
can
more X.
satisfy
Moving this way, you
one
get more
two pairs.
Y. If you move this way, it's more X and more Y. So that can never, these two can never be on the same indifference curve.
Oh, yeah.
Never. So you'll never have the case that the supply curve, indifference curve looks like a supply curve and is like this. So never, no, I don't remember how to write. Oh, for the Chinese, is that right?
Well,
Thank you. Okay,
No,
so
no,
wrong
that's,
side?
no, that's right, that's, yeah, you're right, that
okay.
means blue, bad.
Okay, that's the Chinese word, okay? So never have indifference curve Yale, okay? Never have indifference curve Yale, okay? Because this violates more is better. So you can never have a situation where any 2 points are up and to the right or down and to the left. Okay?
You're right. I do understand now. thank
Okay.
you.
The one thing that might be interesting is on the homework, I asked you about left shoes and right shoes. So this is going to be left shoe and right shoe. Okay? And I draw these indifference curves that you look at and you're saying, I never saw one of those. You cannot ask me that question. And I would say, well, I taught you enough so that you could learn it. The indifference curve connects all points with the same utility. So if I have 2 left shoes and 2 right shoes, and I compare it to 2 left shoes and 15 right shoes, so this bundle, talking to Brett's question before, 2 left shoes and 15 right shoes, right? It's on the same indifference curve. So that's saying that if you give me more right shoes, but not any more left shoes, I'm not going to be any more happy. Hopefully that's true for you. If you have 3 feet, just let me know. I'll give you extra credit. Okay? So 2 and 15 is on the same utility as 2 and 2. So the one thing, I don't teach this, but this is not a hard concept to think about. If ever there's any price on shoes, you know, even if they sell left shoes for right shoes for a lot cheaper. So suppose this is a budget. I'm mixing in something that I covered last time, but I haven't shown you today. If my budget's like this, I'm always going to optimize at the corner. Meaning it never makes sense for me to buy extra right shoes if I don't also buy extra left shoes. So if I have another budget set, then I'm going to have to find the correct next corner. And there I just drew another indifference curve as I needed it, right? And over here for another budget set, meaning if I increase my income, I'm just increasing my income going out, it's another utility maximization point. So all these are going to be the utility maximization points. And there's a phrase called income expansion path. Ooh, I'm never going to mention this again outside of the question being asked, but it's neat to think about. The income expansion path just says, as your income goes up, what are the different bundles you're going to buy? So it's all the what ifs for different income levels. So at this income level, associated with this line, I'll buy this. As I increase my income, I'll do this. So the income expansion path is going to be, I'm just using squiggles so it looks different on the board. It's a straight line on that 45-degree line for shoes. And that should make perfect sense because we always buy left shoes and right shoes together. So that's what the income expansion path, and it's just the name we give to the path you take, picking the optimal bundles as the income is going up. Okay? And if that's confused you, then talk to your neighbor or don't worry about it. Okay? So moving back to this, we have more is preferred to less. The marginal rate of substitution, this was exactly Brett's question. So he asked it 2 slides early. This is, at this point, if I think about the tangent line to this, I'm picking 2 points really close to each other. I'm thinking if I move down a little bit, how much do I have to move over? So that tangent line tells me, oh, that's the exchange of one good and the other good to get me to stay on the same utility. Okay, so change in R and H, the two goods for a difference curve. More is preferred to less. Happy face in the top right corner. Non-intersection, and because if they start intersecting, then they violate some conditions. And transitivity. If A is preferred to B and B is preferred to C, then A is greater than C. A being a point in the bundle space, B being another point. The reason is because every single one of these points is associated with a utility number that we're thinking of. So we can use these things that are true for numbers. Transitivity for this case. So concept check. Any questions before we go to the concept check? Are you ready for the concept check? At least in teams of 2 to 3. What do these difference curves mean? Which difference curves has higher utility? If you already did the homework and know the answer from looking at the homework, then why don't you ask the other person whether they got it before you just show off and brag. Okay? I'm leaving the room so you talk to me.
It means you either hate the other product, it means you hate the other product.
You're probably,
You don't care about one thing, but you don't care about
number of
one
Hershey's that you would be happy with,
Like,
but
one thing is like, yeah, but it's like
more of the Reese's that you get.
because it doesn't matter how much you get on the one, you don't really care. You just care.
Wait, you're saying there's only
I think the one on the y-axis would be the one
Like, it doesn't matter to you how many
what's something you
Hershey's you have,
as long as you have her.
as long as you have
you're kind of part of the team.
5 Hershey's, you could have an increasing amount of Reese's.
The same for every
Oh,
quantity.
so really, as long as you have that number of Hershey's, it doesn't matter how many Reese's you have, you can still have the same answer.
The y-axis is the thing you
Almost
don't
like
care.
you would be happy with, with 5
Yeah,
Hershey's
exactly.
and any number of.
And you really want it. But you can only have 5 of those.
And the other one they want.
It says use the definition.
Wait, one of the
What's the
x-axis would be the
definition?
thing you do like, right?
Yeah.
So the y-axis would maybe
Sorry.
like goat cheese. Fucking hate goat cheese. Katie, that shit. What about you?
Total satisfaction of the bundle of goods.
I like Vince Small.
The total satisfaction.
What did you say for the thing you're allergic to?
Do you
last
have
time?
the same
Oranges.
satisfaction?
Oranges?
I know, I'm so weird. I hate oranges.
That's fine. You're allowed to hate
No matter
oranges.
how many.
Well, I think you have higher satisfaction with the yellow one, but I think it means like
Especially
you would have basically the same the same satisfaction for
No, but I went to entomology as a kid, so I had like a higher threshold.
Right. Okay, that makes sense. Actually, I went to the TA for help with homework.
Wait, so what's
And they said it was just homework.
If A is greater
See what
than
she
B
wrote.
and B is greater than C, then A
What is this,
definitionally
two
must be
straight
greater than
lines?
C.
Number 2.
Oh, okay.
So it's essentially saying if one is less than 2 and 2 is less than 3, then 3 must be.
Oh, she did explain that to me. So she was saying that.
I just don't know what he meant when he
I really
applied
like
the
Twix,
to that. Like,
right? But I don't like
It's
tomatoes. Hypothetically, I do like
Indifference curve 3 is higher than difference curve 2. Indifference curve 2 is higher than difference curve 1.
She was
Difference curve
saying
3 has
that as
to be
long
higher
as
than
you have
difference
10
curve
Twix,
okay, that's it.
our utility is already going to be optional. It doesn't matter how many tomatoes we have if we don't like the
one thing
tomatoes
more than
anyway.
another,
But as
if you
long as
like
we
that
have
second
those
thing more
10
than the
Twix,
third,
we're
you have
happy.
to like the first thing more than the
But if we had 11 Twix, then we would be happier with that situation.
that does make sense.
It's just basically saying economics
Okay.
follows the basic rules of mathematical logic.
She was pretty good.
Yeah, she was always stuff like half.
Do we know how many hours we're getting for the financial studies?
The red line.
10 hours. That's how long it's going to take. I don't know how long it's given.
I think 2.5 hours.
Me, you're so good at it though. Are you serious?
I am
You're so
serious.
good at it.
I
You got the
like-
practice problem right on the first
You gotta try.
time.
No, I didn't.
Oh, I thought you did.
Okay.
Oh, neither did I. Oh, that was the person behind us.
I did not get a chance to visit with the middle, so let's see. Let's go. You're smiling, so I think you got it. So I'll go to the people who aren't smiling. I don't want to. Maybe they're just tired because there's a prelim later. Max and Natalie and Monica. Okay. What do these indifference curves mean? How would you? What story would you make up for this? Or give me 2 points that. So I have Reese's and Hershey's here. okay? So give me 2 points. Let me just let you answer. What do these curves mean? Or give me 2 points that have the same utility. Yes, you wouldn't want one of them. It's related to you don't want one of them. So Max, so how many Hershey's and Reese's here?
5 Hershey's.
5 Hershey's? That's Reese's. R stands for Reese's. What are you just saying on there?
Okay.
So this point, how many Reese's?
0.
0. Good. Said with confidence, Cornell confidence. Monica, how many Hershey's and Reese's here?
5 and 0.
5 and 0 here? Okay, going too fast.
5 and
How far to the right?
5.
And how far up is this one? This point, no, point X. I think it's 5, but 5 and 5, okay? 5 and 5. So let me write that down. 5 Hershey's, 0 Reese's, or 5 Hershey's, 5 Reese's. Okay? Jane, Kathleen, and Togo, right?
Yep.
Okay, good. Which of these gives this person higher utility? Of these 2 bundles. I can't trick you today. You're on your game. Same, okay? Why? Because they are in the same. Give me one word, Kathleen. The first word starts with an I. And Togo? C? Curve. Okay? Same indifference curve. Okay. Indifference curve. Okay? So why might someone not increase their utility when they eat Reese's? They don't like Reese's. So hate things I like to hear in this case, hate Reese's. Or Reese's have peanut butter, in case you don't know that. So maybe they are allergic to peanut butter. I know some of you are allergic to peanut butter, so you will 100% remember this answer on the prelim. It's burned into you. Okay? So you can't just assume everyone likes peanut butter. Some people might have indifference curves looking like this. Which of these indifference curves has higher utility? The yellow one to the right or the red one to the left of the 2 that I have here? Ronnie?
The yellow.
The yellow one. Okay. You said that with a lot of sureness, okay? So, of all the 15 by 15, of all the possible grid points on here, are there any points higher in utility than this point? So I'm asking a question not on the 2. Is there anything that's preferred to this bundle?
Yeah.
Yeah? Okay, what is preferred?
Anything to the right.
Anything to the right. Okay? Which means, how does this point compare to that point? So bottom or top? Which one has higher utility? The bottom. Because you don't like Reese's at all. Okay? So it's not just closer to the corner, it's closer to the corner in terms of elevation and indifference curves. So you can use this kind of stair steps. Step, 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 step. Each step has the same elevation on utility map. So budget sets are combinations of all bundles, so in this case Reese's and Hershey's, that can be purchased with a certain amount of income. So given prices of 2 goods and total wealth or income, what are all the things that they could buy? The budget constraint is the outer edge. So for a budget set, you always want to think there's an income and there are 2 prices, and what are all the things I can buy? Income, 2 prices, what are all the things you can buy? I'm going to flip this so you can see. I'm going to let you write this down for a second. Yeah.
So is budget constraint the same as willingness to pay, max willingness to pay?
No.
It's not, okay.
No, budget constraint is not the willingness to pay. Because budget constraint is actually a bunch of bundles.
Oh, okay. I thought that was saying like the max you would go or something.
No, not the max.
Oh, okay.
So I'm going to skip past the graphical and just go straight to the equation for a second. This would be the equation. So this part of it is how much you spend on the Y good. So if you're buying yo-yos and X-ray machines, the price of yo-yos times the number of yo-yos is how much you spend on yo-yos. The price of X-ray machines and X-ray machines you buy, that's how much you spend on X-ray machines total. Adding them up is how much you spent overall, and income equals that are all the combinations of X and Y that spend all the income. It'll be a straight line. So in this picture where I say Reese's is 10 cents, Hershey's is 20 cents, then the budget set are all the things you could buy. So the budget set just means exactly I can afford it. So I can always afford nothing. And in this case, if I spend all my money on Hershey's, which blindly pointing up there is 20 cents, so I can buy 5 with $1 of budget or income. Or 10 Reese's, which is $1 divided by the 10 cents for Reese's. That tells me the endpoint. This should look very familiar math quiz-wise or the Desert Island model. Find the endpoints by taking your total budget of time in this, or budget. In this case, it's money, but you did something very similar with PPFs with a budget of an hour. You figured out how much time on meat, how much time on fish, add them together, all the combinations to get the spending all the time. So the budget set here is, you can think of it as the purchase possibilities frontier. Like the constraint is the outer edge. So technically the whole set is everything that's less than or equal to income, but more important to me is you can draw the income and then you can think, oh, everything in here is stuff that I don't spend all my money, and the outer edge is where I spend all the money. All the money is income. So hopefully math quiz like, or or bring $1 to a grocery store and look at two goods and think of all the bananas and oranges you buy. Okay. So the indifference curve. Did I switch something? Oh yeah. So I think I agree. So what if there's a shift in this? If there's a shift in income, if there's a shift in price, Reese's and Hershey's, Hershey's used to be 20 cents, I'm changing Hershey's price to 10 cents. You did the same type of recipe. So one of these endpoints is going to change. Okay. Which endpoint is going to change? I think I'll volunteer for this. Kayla?
Hershey's will move out to the right.
Okay, Hershey's will move out to the right. How do we figure out the endpoint if you're only spending money on Hershey's? Someone besides Kayla. Okay?
You divide the income that you have by the 10 cents.
Income by the 10 cents, which is the new price. So you go all the way out to 10. If it helps you memorize it, this point will always be income divided by price of Hershey's. This point will always be income divided by price of Reese's, or the appropriate good on the X and Y axis. So the endpoints are always given by that. But I don't want you to memorize that. Well, you can memorize that, but you should know how to derive it. You should know the story that makes sense. In case your boss is from Yale and you have to convince them that that's the right answer. Okay. So another thing that can happen is suppose the income changes. The income used to be $1 and now it's $1.40. What happens to the budget set? Well, same thing. This is now going to be $1.40 divided by 20 cents, so it's going to go to 7. And that's going to be $1.40 divided by 10. Sorry, $1.40 divided by 20 is 7. $1.40 divided by 10 cents is 14. Okay. You'll also notice that the slope of this is going to be the same, related to the ratio of the two prices. And you can, if you like math, you can calculate what the slope is and memorize it. If not, you don't have to ever memorize it for the class. Okay. So the rest of the concepts in this, in plain language, utility, we're trying to maximize utility. So utility more is better, but I can't just buy everything. The indifference curve tells you everything you'd just be just as happy with all those choices on the same indifference chord, or same utility. Anything up and to the right is higher utility, anything down and to the left is lower utility. So budget sets tell me, ooh, what can you buy? And maximization is trying to combine it all and figure out what is the thing I can buy that's going to give me the highest utility. That's all it is. You can memorize that and understand that story, and when you hear that, it makes sense. That's what is the thing, what is the bundle that I can afford that gives me the highest utility? Or in English, the English that I thought was more clear, that's what I want more than everything else I can buy. Meaning, if I point to a point on the budget, on the bundle space, and say, that's my maximum utility for this budget, everything else in the budget set has a lower utility. So I like it more than everything else. Okay. I'm going to add one hokey thing, and if you really like this, tell me in the aha, that's a good thing. So, okay, so when you have this budget set, okay, this is, everything here is okay, everything here is right on the edge, and everything out here is forbidden, okay? So if you like stories, call that forbidden forest to match with utility mountain. So you want to get as high on utility mountain, but don't go into forbidden forest, okay? Forbidden. Okay. So what does that mean graphically? So we model consumers making decisions by maximizing their utility subject to the budget constraint. You might have read that in the textbook. Make decisions is choose bundles. So you're choosing the bundle that has the highest utility subject to the budget constraint. I feel like I'm repeating myself, so this is very important. For this model, we assume that any money not spent on either good gets burned or taken away from you. This is commonly referred to as use it or lose it, or no carryover budgeting. Okay? If it helps, pretend like these are decisions using cruise money. You've been on a cruise. I think they give you cruise money, and there's no purchasing power if you don't spend this money when you leave the cruise. Okay? Students often get confused and say, oh, this point has the same utilities but spends less money, so it's better than the other point. This is incorrect because of the use it or lose it rule. Any money you don't spend does not carry over. So, what I mean by this, and I will tell you exactly what maybe 20 to 30% of students get wrong, I ask them, this is point A, this is point B. And I ask them, which one do you prefer? When I say prefer, I mean higher utility. Okay? So which one do I prefer, A or B? And this is an indifference curve, and this is a budget constraint. Okay, which one do I prefer, A or B? Just say it out loud.
It's the same.
Same. Oh. Okay, so let's go back. Indifference curve means same utility. In fact, I wrote it earlier. So same because of indifference curve. Same utility. Same utility. Same elevation. If you got it wrong and you like stories, same elevation. Same level on utility bound. A and B are the same level of utility bound. Okay? So neither. So A, same utility as B.
That's even with the use it or lose it, or no?
That's even with the use it or lose it, because higher utility only refers to the utility of the bundles. It doesn't incorporate money in there. So B doesn't spend all the money. So that's how we talk about in econ. This is more just vocab and getting a consistent vocabulary. A spends all the money and has a certain utility. B has the same utility but doesn't spend all the money. Which doesn't say B is better, it just says, oh, I can move further out to go do better things. So this further out.
Wouldn't you not if you were on a cruise and you have a certain amount of money, wouldn't you want to spend it all no matter what?
Yes.
Okay.
So good insight. Because of that,
That's what
maximizing utility also refers to finding the point on the budget constraint. So what Will said, it'll always be on the budget constraint. So you can limit your search. When I say is it utility maximizing, you can limit your search out here to this line. And then you're trying to find what point on this line is the highest in utility. We know it's not A because we know A is the same as B, and all of these points here, in fact, every single point, including in this box here, all of those points are preferred to both A and B. So I'm just trying not to draw the exact thing. So all of these points are preferred, all of those bundles. Okay? So not all of them are attainable. The attainable section is everything in here. I'm just trying to indicate. I'm not going into forbidden forest, okay? I'm staying in on the edge. So all of those things are attainable within my budget and have higher utility than A. Okay. So maximizing utility always refers to finding the budget constraint on the highest indifference curve. So when we want to find a point that is utility maximizing, is at the point on the budget constraint and indifference curve where they're tangent or at a corner. So the other way of saying it is if you move in either direction along the budget line, your utility is going to go down. So let's see what this looks like. Well, let me do it once without multiple curves on. So if this is going to be my budget set or budget constraint, and this is utility maximizing, then the only point on that elevation, indifference curve, okay, the only point at that elevation, it will be that point. Okay, every other point that I could possibly buy, excluding that point, so the whole entire budget set excluding this point, is going to be a lower utility. Like this point might be on this indifference curve. This point might be on this indifference curve. And there are indifference curves everywhere. So no matter how close I get, there's going to be a lower indifference curve. This is the highest elevation I can get to, given this. Megan, and then I think I saw another hand, but it went down. Megan first, and then I encourage you to.
Like on the graph that you did beforehand, that intersection would not be usually maximizing because it's not tangent to it. So
not tangent. If it ever crosses through, it's not going to be. Okay? Because if it ever crosses through, you can always move to the right from where you crossed through, or up and right from where you just crossed in, and you'll be at a higher elevation. So when we have a bunch of indifference curves and we put in a budget set, so the way, it's a little bit of a disservice because the way we have to teach it so that you can communicate it back to us is we'll give you an indifference curve and say what budget would make this point utility maximizing. Then you just draw it as tangent. Or if we want to make this point as utility maximizing, you would draw it so that that's the budget set tangent to it. The reason I say that's unfortunate is it makes you think that this is just some sort of exercise where we adjust the budgets and go randomly. That is a confusing one. Okay, so this point will be the utility maximizing for this budget set for the person with these indifference curves. If we do some other, so in this case, we have the y good and the x good. I made the x good cheaper. So see, this is a certain level out. I made the x good cheaper so I can afford more of it. So that old point is no longer utility maximizing. There's going to be some new utility maximizing thing here. Okay? The red dot is not utility maximizing. Okay? The red dot is not utility maximizing because, as Megan said, anytime the indifference curve crosses over, you're going to have places that have higher utility. The one exception is when you're in the corner, you can do some things. the corner example, which I've done on exams, so you can look for it on an old exam. If I have the hates Reese's indifference curve, this is going to be the point that maximizes utility, which makes sense. I'm going to spend all my budget on Hershey's because I hate Reese's. That's going to be the budget constraint. If that's my indifference curve, I can't reach this indifference curve. I can reach in this indifference curve. This indifference curve, there are things I prefer to it. Justin first.
Yeah.
If you're ready.
So what you were saying with Megan before, you said if it passes through, then what happens? It cannot be something?
It is not maximization.
If it passes through, it's not
It's
maximization.
not maximization. Meaning it's not the highest level I can get to. Because all of these levels are higher. But Professor Chong, there's no indifference curve there. Well, earlier on, there's an indifference curve through every single point. So there's going to be some indifference curve. So that might be the indifference curve. So the way we teach it is we don't give you an equation of every single possible indifference curve, although we could. But we generally do not, unless there's an easy way to describe it. So what we'll tend to do is say, draw a point that could be utility maximizing and draw an indifference curve that's consistent with that. So that could be it. And in this case, right, if I'm like this, and then I have another indifference curve here. If I want to make this the indifference curve that gives me the highest elevation utility amount or highest utility, then the easiest way is to make a tangent a little bit there and then make it kind of line up, never going up and to the right. And I'll just say indifference curve special because it's the special one. Okay. Indifference curve 2 is higher than indifference curve special, is higher than indifference curve 1, but indifference curve special is the highest indifference curve we can get to. Can we afford this point, which I'm labeling A? Can we afford A? No. Okay. Can we afford C? Yes. But why isn't C utility maximizing? Many things. It's not on the budget set, so there are things where I can get more of both. And it's not tangent.
You're losing money.
Most importantly, there are things I can buy that are higher. Okay. So, concept checks. Do indifference curves change when the budget set changes? Okay? I'm not going to answer these, let you talk about them, so let me read them so that you have them on your head. And second, given the budget constraint in the figure, which bundles spend all of the consumer's income? I'm adding some bundles. Which bundles spend less than all of their income, and which bundles cannot be afforded, otherwise known as forbidden forests in Looney Tunes Econ Land. Okay? And last one, which two bundles have the same utility out of the four that are drawn there? Hopefully this is razor fast, but if it's not, talk to the person next to you or clarify it. It'll make it clearer, even if it's not
Is
solved.
the forbidden forest closer to the origin or further from the origin?
Further. Forbidden forest is everything past that diagonal line that's your budget constraint.
Basically, anything you can't afford.
This is assuming that we don't have
Wait,
credit cards,
so,
we can't.
sorry. This split,
Pay with money you
this
don't got.
shaded region, I
Is
wrote,
the place that you can't spend.
you
don't know
cannot
again?
spend?
Can spend.
Oh, so I did it
As
reverse.
much money you have, yeah.
And then this is the forbidden part.
Yeah. That's what credit cards do, right? They let you spend money you don't got, right?
So the first one is no.
Debt, whether or not you have debt is a philosophical question.
Second one, given the budget constraints figure, which bundles all the customers' income. That thing. So the yellow one.
The difference curves change.
No, they don't.
change.
They don't.
The budgets have changed. You just might move to different ones.
No, the curves stay the same.
I don't think. Yeah, I think things don't change. Different
Yeah.
budget set.
Different, yeah, it's
Because
different.
like, I don't think the budget. I mean, I don't think the difference curves are depending on how much the
Yeah.
And the blue one.
I said I don't
Less
think that
red.
the indifference curves
Cannot be
change
afforded is
when the
like,
budget set changes
green.
because usually your happiness is as well.
To both have the same utility.
In this case, I don't think your happiness is
Same
dependent upon how much
utility
you spend.
is the red and yellow. Yeah.
Is that what you're saying?
I can give it, honestly, I'm one.
I can even hear.
I'm lost.
I really need to do the
If you're like condensed, it makes it
Well, the second one.
like you have so much time to get to this point, but yeah, 5 minutes. I don't mind sitting in front of you at all. My only thing is the beginning.
Professor Chung, so we were both saying.
Like I do when I'm talking. But like,
What's your right time to think that you're allergic to one
and
thing?
I'm not like comfortable up there, but like I'll look
Do the part where it asks you for one thing that you're allergic to.
looking directly in your eyes, and I'll be like, that would be like the exact same thing. Not the best. Yeah.
Find something.
Furbies.
You can add them to the graph. What I mean is the indifference curve. Do they like start rotating or they start?
That was a good idea.
So I don't want you to use the word change. The answer is it won't change, but I'll tell you the right vocabulary. Yeah, Brett, do you want me to? What I mean is changes it.
No, that's not saying,
But even though I've only drawn 3, there's actually 3 events.
yeah.
So the one that's here, does that disappear suddenly when the budget is out? No, I mean, we draw it in, but it doesn't change.
No, it gets worse than like when it's the only energy drink they sell at Cornell.
Yeah, so it's
Horrible.
that like red line and shit.
I do like coffee, but sometimes it's not look, there's fingers, I don't know what that is.
Points of view.
It's still active.
So as in shape and like.
That's how you're sorry.
Then they wouldn't. I still think they wouldn't change it. And the second one,
We'll have the lowest higher utilities. So it's pointing here. That's also.
Maybe which one they'll spend all. Isn't that the stuff on
which one
it?
they'll spend all the consumer.
That's on it. Remember, so forbidden flowers is anything above, and then which spindles will spend less. That's closer to the bottom.
That's what you can.
So then the one that spends all of their income, wouldn't that be the one with the yellow dot? And then spends
No, it would be all of them on the blue line. Wouldn't it be? Anything on that line spends all of the consumer income.
Okay.
Unless I'm way off here.
Hey, Keel, do you get, okay, so.
Okay, I'm going to answer question 1. Okay, because when I asked do the indifference curves change, what I'm trying to get at is if I ask you the utility of a good, like a bundle 4 and 12, you tell me, you consume it and you say, oh, that's really good. And then we connect all the points, if I ran the experiment, all the points that are also similar good or similar elevation. So when the price changes, the amount you enjoy a good does not change in econ. Does not change in econ, right? So that's why your willingness to pay didn't change, right? I was willing to pay $8 for the taco, and when the price went down, I was still willing to pay $8 for the taco, but I was happier when the price went down. That $8 is kind of connected to utility. It's not represented on here exactly, but it's connected to utility. So so those numbers that represent utility that we connect when we do an indifference curve, those do not change. The exception is when we go outside of econ, people there's something called behavioral economics or psychology, where they start saying, oh, like when you go buy a leather jacket, never pay full price. You never pay full price because they're all marked up 2 to 3 times what they're willing to sell to you, because when they say it's $1,000 and they sell it to you for $400, you're excited. You feel like you got a better deal. If you walked in and the sticker said $300 and they said, oh, but we're not selling it for $300, we're selling it for $400 today, then you'd be like, why are you selling it for $400? So depending on where you frame prices, in real pricing land, you can confuse people and get them to give you more money, which is a good thing. But in econ land, we're trying to say, what if everyone was Spock from Star Trek? And everyone is not affected by those price distortions, then Spock would not care whether the prices are lower or higher. He would just say, I prefer this, the same as this, the same as this, the same as this. The other distinction is someone said, well, when you draw this budget set, you draw another indifference curve. Correct, you draw that other indifference curve, but that indifference curve was always there. Every single indifference curve is always already there, it's just not drawn yet. Okay, so that's what I mean by, so hence, the indifference curves do not change, we just draw the ones we need. Okay? Employees asked it as change, but no one has ever told me that they get confused with change and adding a curve. So I would say, you know, is there any way this is going to shift like that? I might ask it that way. That would be a little clearer. Do we want to do 2 and 3 or a question? I wasn't sure who was asking the question. Okay, 2. Given the budget constraint in the figure, we have 4 colors: green, yellow, red, and blue. If you're colorblind, I'll say it again: green dot, yellow dot, red dot, and blue dot. Given the budget constraint, which bundles spend all of the consumer's income? I'll go to the left. So Eric, Michael, Arun, and Darian. Okay? Which one spends, well, why don't I just give you a different dot? You tell me which category. Okay? Do you want me to start at Darian or start with you, Eric?
Start with you.
Okay. Blue, do you spend all your budget? Can't afford it, or less than all your budget?
Spend all your money.
All your budget. Good. Michael?
All your budget.
All your budget, okay? Arun? No? No, you can't buy it, or no, it's not all your budget, but can you buy this?
You can still buy.
Okay, you can still buy it. And then Darian?
You can buy it.
Cannot buy it. Okay? So I could pick any of these numbers on here, and you should be able to answer that question. Okay? And which 2 bundles have the same utility? Megan, do you know?
Is it the red and the yellow?
The red and yellow, because they're on the same indifference. Same indifference curve. So if you can remember that step, same indifference curve, instead of panicking and thinking, Professor Chong likes green, so it must be green, or he's trying to trick us, it's not green. Okay? So, which bundles spend less than all their income are things that are closer to the origin from the line, from the budget line, farther from the origin can't afford, and then which 2 bundles have the same utility, same indifference. Okay? Relating prices and marginal utility at their optimal point. So this is the idea of bang for the buck. So if you have your quiz from last time, I'm not going to make you turn it in, but I just want to refer you to it. We started out asking you about movie tickets and vacations. And obviously you want a vacation more than a movie ticket. But why isn't it that we all buy vacations? They're more expensive. So the way this makes sense is we have this idea that's bang for the buck. We take the extra utility from buying a vacation or a movie ticket, and then we divide it by price. And that gives us a sense of how the extra utility is related on a dollar basis. So those of you who've already started the homework, you've gotten a good taste of this. What I force you to do on that is I force you to think about how much you can buy with $1 worth of a good. And with $1 worth of a good, the amount I can buy is $1 divided by the price of whatever good that is. So if I had something like, if my marginal utility is equal to 5 for,
5 and 6.
thank you. Okay. Marginal utility for tacos. Let's do tacos. I love tacos. So marginal utility of tacos is 5 for me. That tells me an additional unit of tacos gives me 5 utility. This is kind of like a slope in utility land. Some people like to think of this as change in utility over change in quantity of tacos, starting from whatever point we're starting at. So using this as a slope, if I have plus 1 taco, that's like plus 5 utility. So I'm going to use this utility. If I have plus 2 tacos, I can think of it as an estimate plus 10 utils. It's not going to be exactly plus 10 because marginal utility will go down, but I can think of it as plus 10. Now when we go $1 divided by price, we're usually doing something like 1/10 of a taco. So if I go plus 1/10 of a taco, then it's going to be plus 5 divided by 10, or 0.5 util. Okay? And I can also use this going backwards. So minus 1 taco, I can think of, well, the extra taco gave me plus 5. If I did not get it, I would get minus 5. Or minus 1/10 of a taco would be minus 0.5. So I'm just using this as a sense of a slope. So then when I use that slope and multiply by $1 over the price, that tells me the extra utility of $1's worth of Reese's. And this is the extra utility of $1's worth of Hershey's. When we compare these, we get to figure out what the optimal point is. The one thing that changes on your homework and in the book is people don't write this dollar all the time. They just cancel out the dollar on both sides. And so they write it like this. That's the first thing they change. The second thing they change is on the homework, I have you write marginal utility of Reese's over price of Reese's. Instead of writing the equal sign, I have you subtract away the other side, marginal utility of Hershey's over price of Hershey's. And if I subtract it away in this case, it's going to equal 0. So when these two are equated, that means if I spend $1 more, so this is plus $1 of Reese's, this is plus $1 of Hershey's. The $1 is very important. It's not plus 1 Hershey's, it's plus $1 worth. Just like I'm not just comparing, when I buy a vacation, unless I want to go in debt very quickly, I don't want to get confused and think, oh, I love vacations. I'm going to buy a vacation instead of a movie ticket. Because I need to think of $1's worth when I'm comparing. So $1's worth of the things. When they're exactly equal, then this tells me that I'm no change in utility either direction. No change in utility either direction on the budget set. So if I'm here, it means if I move Hershey's, Reese's, if I move over $1 and down $1, even if it's not the same amount, over $1 and over $1, down $1, I'm going to still spend the same money. So I'm going to be on the same budget constraint. Or if I go up $1 and over $1, I'm going to be still on the same budget constraint. So this says no change in utility either direction, which generally means utility maximizing. The only exception is if you're already in the corner, then you don't have to think about moving any lower, because you can't move any lower. Yes, Will?
Does that mean you like them the same amount or no?
It doesn't mean you like them the same amount, because just like movie tickets and tropical vacations on the quiz, I like tropical vacations. It means I like $1's worth of it the same amount. So I would much rather get, that's if I'm optimizing. So most textbooks stop you at equals 0, and then all you remember is the equation, and there are very limited things I can ask you when it's just the equation. So I like to go a little further and say, the idea is the last dollar spent on either good does it give the same utility? What if it doesn't equal? Now if it doesn't equal, then this means this won't equal 0 anymore. So there's 3 conditions. So if it equals 0, it means there's no change in utility. If it's positive or if it's negative are the other 2 conditions. So the expression here that is larger is going to be the thing that has more bang for the buck. So if I am, ignore this text for a second, and just look at this small little box here. So marginal utility of y over price of y, marginal utility of x, price of x, I tell you the y over the price of y is bigger than the x over the price of x. Marginal utility x over the price of x. which side has higher bang for the buck? Okay, the Y side, because that tells you it's higher. Okay, this tells you if you give a little more Y, but a little less, $1 more Y, and $1 less of X, you're going to go up like 5, but down a smaller amount. So you're going to be higher utility. If you can remember that story, that's great. So this tells you if you're on the line, which way moving is going to get you to higher utility. When this is true, it means more Y. Let me slow down. This is Y. So more Y, less X. Staying on it because I'm doing up $1 and over $1 will end up being higher utility. So in this case, at the red dot, this is going to be true because your utility is going to be higher here. So that's the graphical story, which is very complex, meaning lots of moving parts, but each individual step is pretty small. The missing step that most students forget is the story step, which is where is bang for the buck higher? So one of my favorite questions is to ask, at this point, which way do you want to move? Up and to the left or down and to the right? And then I ask us, they usually get it right because graphically they can get it. And then I ask, which of these are true? Y is greater than X, they're equal, or X is greater than Y. And that's where they say, oh, this wasn't the equation I read in the book, I can't remember. Okay, which I don't like because I want you to beat Yale, okay? So remember, the thing that has higher bang for the buck is which way you would be higher moving, which direction along the budget line you'd go to a higher utility, higher elevation utility mode. And I walk you through in gory detail with lots and lots of words that you hate reading because you want to just add 2 numbers on the homework how to rationalize this between salads and pizzas using variables rather than numbers. Here's a place where we can use numbers, okay? This concept check. And this is the corner example exception. How are marginal utility Reese's over price and marginal utility Hershey's over price of Hershey's related at this yellow point? So you remember the steps, so let me just tell you. At this point, we were thinking about which direction we want to go to get higher utility. Don't just think that, well, I don't want to give it away. So think, don't just think, oh, up is good or down is good. Think which direction is higher utility, okay, which you have to look at in difference curves to get. And then based on that, that will tell you which has more bang for the buck. I want this concept check, so talk to the person. This is confusing. I don't expect you to get it immediately, but if you puzzle and talk about it, I hope you can get it. Okay? I gotta leave and come back.
So we were talking
It's
about
technically the same.
the lower
Why not?
Marginal utility.
So, yeah.
Because on these curves you don't like.
yeah, you don't like Reese's, so like the less amount of
No,
Reese's
no, no. I
you
said
have
like
right.
why would that make a difference? Technically,
Because you want to be closer to that yellow curve.
You don't want any Reese's at all.
You don't want any. No, you don't want any.
related to the yellow point.
Yeah.
I
So
understand that. So then,
Because adding.
I don't think it would make a difference because your budget can't get to the yellow line anyway.
It can, but there are an infinite number of lines between them. There's an infinite number of marginal utility curves.
So you're trying to go down, right? In this case, so that higher margin, so the higher one is H.
You want to go
H
down.
gives you more, H has more marginal utility, and in this case, R has very little to no marginal utility.
for this person at least who doesn't like Reese's, right?
Up and to the left.
This is a person with severe peanut allergy. Peanut allergy.
Or just doesn't like Reese's and is a bad person.
which for this one we wanted to move up to the left.
Because for that one, the higher utility was over there.
Maybe you could delta U to
But why is it? Isn't it like the same? What's like the difference?
Well, this person really likes Hershey's, so
So imagine if we had this,
Higher bang for the
and you need the utility, like let's say the budget set is
Okay, let's
right. So I'm gonna just try to truncate it. Okay. At this point, even though let's say at this point it looks like you want to go up into the left, but these are the things you can afford that are a higher utility. So imagine if this was kind of down and then suddenly skewed to the right, and I had a budget set. The right's still higher.
Because you can't afford that.
You can't afford this, but these are lower in difference. You just have to think which side is the higher in difference.
So then, but I don't understand, because this, isn't that still a lower indifference curve?
No, those are higher ones. Because the higher one is actually here. So the thing that's happening is if I have an indifference curve and a budget set, if I'm over here, I want to move down and to the right. So this case is kind of more like this. Or I don't know if graphically that helps.
Yeah, that makes sense.
Budget curve, indifference curve. So the indifference curve is kind of coming from above and over. So these are the plus, happier, and these are the things I can afford that are happy. So it's more like that point.
Okay.
You want to look at the
Last 35.
Yeah, budget line.
How you doing?
Good.
You want to
Understanding?
Yeah, I get it.
Nice. I think I understand that, so I should be able to
in this case,
Randall's doing all about that relationship curve thing. So now I understand.
the right. And so,
It's like,
At that point,
Sorry.
I was like, yeah, I did not
it's
understand.
also in different curves.
We don't pass it on it though.
sort of like less for marginal utility
Yeah.
versus
That's
more person likes
little
gas, but doesn't like space even if the amount of bases increases.
How are these related at the yellow point? First, let me
Yeah,
ask you the question before. What has a higher utility? This point or the yellow point? This point right here or the yellow point? Everyone together?
Same.
Right, music to my ears, okay? Ignoring the budget set, because we're just thinking utility. What has a higher utility? The yellow line or the red line?
Yellow.
Okay? So I could draw more difference curves if I need to. So am I going to be higher on this side, higher utility, or higher utility on this side? So higher on this
Right,
side,
yeah.
this side, okay? Because if I could think about it, draw my elevation and I look from there, I look at the point at the top of the mountain, and everything in that direction is the higher side, okay? And then these are things I can afford that are on the higher side. Higher mountain, but not forbidden forest, attainable forest, okay? So these are all the things that I want, so I want to move in this direction. So which gives me more bang for the buck? So this is where you have to slow down and say, I want more Hershey's, less Reese's, that will give me higher utility, so Hershey's gives me more bang for the buck. And in fact, in this case, there's a special situation. This person hates Reese's, so the marginal utility of Reese's is exactly 0. So this is a helpful, in this specific case, it's a helpful way of saying, oh, the marginal utility of Reese's is always 0, so this one is always going to be higher. But the other step-by-step way is start at that point, figure out which side's higher, and then think what direction that is, which direction you're going more to the right, which is H, or more up, which is Y, good, the Reese's, and that's the thing that has more bang for the buck. A lot of words there, hopefully consistent stories.
So conceptual.
I mean, I know it's a consistent story. Hopefully in your head it's a 90% solid, consistent story solidified by the homework in a few hours.
And then answer box versus MUR over price R equals 0. How did we find that out?
So in this case, the mu over r over price of r equals 0. That's true when mu r is 0. And this person hates Reese's. Remember from the other concept check?
But if it was something that maybe like a little bit.
So if they like Reese's a little bit, then if you took away one Hershey's, you'd have to give them a lot of Reese's.
No,
So
it's
you
just like
wouldn't
a
have the
different,
zero
oh,
anymore. But, so you can't use the zero root. Then you have to go back to which side do I want to go on.
So how, just for an example, then how would you find out what marginal utility of H is over price H?
So marginal utility of H over price H. You're tempting me so much because I want to teach this to you, but it's going to blow up some minds if I do it. So if you want to know, I will show you in office hours. Otherwise, I will not tell you. The thing I can say is the slope of the indifference curve is the ratio of the marginal utilities.
6.
So I'll just say that again, but you can forget. Slope of the indifference curve is the ratio of the marginal utilities. So very quickly, and then I'm going to save your question for after class if you really want to know, because I just want to show this before, because that's the end of it. Yeah. So what are we doing when we're doing a demand curve? We have a budget set, a price of one good, a price of the other good, and income. And then I can change the prices of attractions here. I've changed the x-axis to attractions. So I'm lowering the price. As I lower the price of attractions, look what happens. The quantity consumed of attractions is going to go up, meaning I'm moving more to the right. So the same recipe when we do a demand curve, all we're doing is holding income, holding price constant. We're saying what if we change the price of a good? It's just drawing different budget sets and then finding the optimal points and then making a table. That's how we would make a demand curve from these things. Okay, so from that, I am going to stop and talk about some of those things next time. You have everything you need to do the homework. If you did not pick up a homework cover sheet, go ahead and grab one. If you did not pick up a homework slide, pick one up. 15 seconds earlier.
Stop using it?
Yeah.
I'm trying to emphasize that